Now in this session we are going to look at the advanced water management or rain, water and soil conservation systems, and actually we are going to delve in more of rainwater harvesting systems. And maybe a big question will be, because there are a lot of slides, but it's good for us to internalize, to conceptualize what we are looking at here more than capturing every kind of detail that you would probably be having, because we need to use a practical approach to execute these on the ground. You ask yourself after this, have I, yes, we have achieved the aim of this interactive session, but what is my takeaway, you see? Now, what Mr. Njema has just presented brings a good foundation to what we are going to discuss here, because he has elaborated a lot about AI, and that is the main area that I'm going to actually delve, and for a bigger part of the presentation, the use of technology. But then, given that we are looking at advanced water management, that is advanced rainfall water harvesting systems, someone would ask themselves, or maybe would ask each other here in an interactive session, possibly you come from an area which experiences some patterns of rain, be it a lot or little, but given that we've been collecting that water, if for them that do not practice irrigation, maybe we would ask ourselves, what percentage of water do we collect during the raining time? If someone would ask a random question, you don't have to be accurate. What approximate percentage of rain that falls in those 2 hours or 1 hour did you collect at home? Maybe a guess. Maybe a guess. Someone would make a guess. 5%. Maybe 5%. Because it's the water that actually rains within the vicinity of the roof, because most of us use the roof. And so that means about 90 to 95% of water is kind of wasted, because, you know, it goes to the ground and probably the soils do not have proper filtration. So after 2 weeks of maybe experiencing some sunny weather, we have lost the moisture content in the soil, and we cannot use that again. And that brings us to some consequences, like having people like me who grew in a village which is well blessed with rains, but realized that at some point we go and buy vegetables because it is a drought season. Now we are challenging all of us to embrace advanced rainfall water collection systems and enhance the traditional ones, so we can have adequate water that can be used, one, during planting seasons, and even during seasons where we don't have adequate rain, but we are still practicing farming. So that is the essence of it all. So let's delve into this right away. So so the main, the main aim of this is actually to have a critical understanding of the advanced harvesting and soil water conservation techniques. You see, we are not just covering water harvesting alone from the rooftop, but we're also looking at how do we conserve the moisture content in the soil to sustain farming. So that will be achieved by, one, looking at the underlying principles for advanced rainwater harvesting, which will be our actually main area of focus when we shall actually discuss technology and use of systems that are enhanced besides traditional. Then we shall evaluate actually different structures, understand the benefits of conserving water for agricultural use, because that is the essence of it all. Crop production mainly relies on the availability of water. Part of it is actually technology, as Brian had raised before. We would look for species, maybe do some genome research and come up with species that are maybe drought resilient and all that. But then, for the species that are not drought resilient, how do we conserve this moisture? Then now we shall actually examine specific techniques for retaining moisture. Then we shall have wrapped up our session for advanced rainwater harvesting. Now, why? why do we look at advanced rainwater harvesting? You know, there are critical aspects in advanced methods of rainwater harvesting, which we are not only considering the quantity of water as I have introduced, but we're also looking at the quality of water that we are harvesting. You see, you know, there are very many uses of water. There's some water that you would prefer to use in irrigation, but you will not use that water for drinking. And again, because we have scientists in the house and people who are doing major projects about health and all that, you've realized that water is one of the elements that is so critical in human health. What we ingest, what we use for agriculture, you know, runs in the food web to other organs and organisms. So it's a very critical area. There is no way you're going to have collected water from an industry that disposes mercury anyhow, use it for irrigation, and expect to have a zero intake of that water. So we are also going to look at why is it that these proposed methods are more efficient than the traditional methods. So there are these three reasons or the challenges that we're going to address. Urbanization, as I've mentioned, I don't want to use a very critical example. I want to use an example that we can resonate with within. There is Njoro Canning here. Every time you see smoke in the air, that is pollution. So when it rains, be sure that that is not pure water. So probably there is some contamination brought by urbanization. And this is what happens in urban industries, urban areas. Then climate change, as we have mentioned, because of scarcity and maybe an equal distribution of rains. Then water scarcity, as we have said, because as you look at the rainfall patterns for them that have examined the weather, then you realize that there is a significant risk of having insufficient water for farming. Now, what are we going to achieve using this? Or what is the main aim of us settling for advanced ways of storing water and collecting water besides the traditional ways? One, we want to maximize collection, as we had seen, because relatively, as Bishop had mentioned, we collect about 5%. Can we collect more? Now, we want to enhance the quality. Besides just filtering physically with the normal filters, can we do away with some bacteria, some microorganisms, depending on the use of water? Yeah. And then we also want to, of course, enhance storage, then smart use and distribution, as Mr. Njema had mentioned. Having use or proper use that is targeted on what has to be used. Then now, we are going to look at different systems, and I'll mention as I pass through. And this will be a key takeaway for us. It's good for you to note down, so we can do more Googling, more research, and find out how does smart rooftop system work, how does underground modular tanks work, because we don't have adequate time for all this. But then these are some of the systems that are actually enhanced. One of them is smart rooftop systems, and this entails things like self-cleaning gutters, fast flush diverters, IoT sensors for real-time monitoring. I've looked at these, and I was almost being reminded of a memory that I've had just today in the morning. You know, I was on the roof, and I don't know whether it was by chance, by good luck or bad luck. I had to look at a gutter, and I was like, oh my. So this is the water that I'm drinking. It was very dirty. So you see, this is a technology that takes care of stuff. For those that are sensitive to water, you know, there are those guys on Okwambia, they are so sensitive to water. You'll find out that they take some water, and in 2 days, 2 weeks, they have issues. So those are some of the systems. IoT, we shall look more into sensors, as Mr. Njema has discussed. We'll elaborate more on that. Then underground and modular tanks, saving space and having tanks underground to collect more. Recharge structures, that is having bore wells to replenish supply. Then we shall also look at enhancing the quality by advanced filtration. Of course, for them that are looking at methodologies that have been, or techniques that have been pointed out here, chemists will be very, very happy somewhere when they see this. Charcoal filters to UV ozonation and membrane filtration for potable water, things like reverse osmosis and all that. These are basically techniques that are used to filter even more. You know what the basic filtration techniques are used for for maybe dust particles and such like material. But you want to do away with the bacteria, you want to do away with that microorganisms, then we employ filtration techniques. Then we shall look at green infrastructure, of course. Part of it we shall discuss, and AI smart control, because we are moving to besides collecting water for another use, how can I collect water and maintain it within the plants? Next. Yeah. This is an important thing for us to actually think about, and it is an important thing for us to reflect on it. And maybe I'll ask as a question, and I'll probably ask you in advance not to feel offended by the question. We've embraced AI, haven't we? So, in what ways have you used AI? In what ways have you used AI? Maybe we'll just choose randomly from the far end. AI. In what ways have you used AI before? Okay, for me, maybe let me set the stage, because I know someone is afraid of saying I've used it to do my assignment. I've used AI to do assignments. Okay, now, how about you? To do assignments, research.
Mine is weird one.
A weird one, yes?
To cheat in an exam.
To cheat in an exam. To cheat, as you've used it as a brain. Okay, umetumia kama running mate. Okay, he has used it as a brain. Okay. Now, to the far end, the last one. As a therapist, actually. You're like, you know, I'm feeling bored and what can I do, you know? Then it recommends that you take some cappuccino. Then you realize that the pockets are open. You Google again, ask it, what could be the best option besides cappuccino? It gives you strong tea. So you realize that a better part of us have used AI for assignments and such stuff. But then we've not extended its use to a lot of these activities. And maybe I'll be skipping some of these aspects. But have you ever asked yourself about how you can use AI in any other thing besides just asking it question and answer, and it gives you the answers and all that stuff? You see, its use is extended beyond that. The last year, maybe in 0 minutes, someone just taught me something to do with Python coding, and I saw this stuff and I was like, oh wow. So I'm using ChatGPT to generate a code that I would have written for a long time. For them that have coded, you understand this. And so I was like, AI is a big thing. And because Mr. Njema has reminded us about the seminar that was held here, this world of AI is inevitable. So it is about us positioning ourselves to embrace this AI in meaningful ways, and this is one of the ways. IoT, as he has mentioned it, there is an elaborate model that he has presented. I have another one here where we can adopt this and use the technology, sensors, predictive management, as for them that have used predictive analysis, to determine the water quality. Maybe parameters like pH, parameters like temperature, parameters like moisture content and all that, which are very, very important for production. So this is a model that demonstrates the flow. And it is actually on maybe the next slide. We shall see how AI can be embraced in determining the quality of water and determining the moisture content of water and such like parameters. So you see, you can fine-tune Internet of Things and machine learning, you know, that is the old concept, to understand that these things are taught, actually literally taught, so that at the end of the day, I have sensors that can help me to understand that this soil is effective for plant growth, and that is where the concept comes in. Monitoring system. First of all, look at this. It is actually an automatic. Okay. So it's actually a monitoring system which has a lot of things. Maybe I'll just describe briefly how it has been used. So you're seeing this is the data that determines the quality of water we have pH, we have turbidity, flow rate, and other factors like dissolved oxygen and all that. So the sensors detect this, then they send the signal to the dashboards for actually evaluation. Then that to the automatic gate or adjustment where now an activity is done to respond to that signal. If the level of maybe flow rate was low, then there is a responsive action here, which sends the feedback. Then after the feedback, there is another feedback here to see whether it has been stabilized. Now, such systems can be applied, especially when we collect adequate water. That can be applied in different uses, industrial, agricultural uses, and all those domestic, which are actually mentioned here. So the benefits will be one, the systems, urban systems. For example, Nairobi, there was a time when we had floods, I think last year but one. We shall have addressed this because we have collected water when it's there more than enough, then used it in a different way. Then also reduce aspects such like energy that could be used for pumping. We've collected enough water and therefore we don't need a lot for pumping, yes. So I've mentioned a lot of stuffs which are interesting, yes, but then there are some of the issues that come up with something that is interesting. You want to buy an expensive car, you have to be ready to fuel. So you want to adopt this system, then you have to be ready with initial costs of setting up, and then actually be ready to maintain the same and be ready to maintain the quality of whatever you have adopted. Otherwise, these challenges won't have to scare us because, you know, this is the future, the inevitable future that we are going into. And we are actually adopting energy that is sustainable, that is green energy that is sustainable, solar source. We can enhance the distribution of water and practices such as AI-driven forecasting, so that we can, using machine learning, we can determine more and have more accurate ways of determining weather conditions, so as we can enhance our farming. Now, this is actually a small comparison that shows different structures, that is dams, sand dam, as we had seen in the previous presentations, farm pod and terraces, and it is actually demonstrating how much you can collect using these structures. So you see, the important thing is the storage capacity there, and then the cost that is associated with that. And then besides the costs, now, how convenient is it? So you see, sand dam, for example, helps you collect this capacity. Is it enough for your acreage? So those are the factors that you also consider. So besides proposing a structure for you, it is also good for you to consider and see how effective is it for my use. Now, I'll mention a few interesting things here, and you'll agree with me that they are interesting actually, about collecting water or water harvesting. And one of them is actually rooftop rainwater harvesting. It has been traditional, we know that, but there is one addition that I'll make. That one, besides having the rainfall rooftop water collecting systems, we can integrate Internet of Things so that we can use it for groundwater recharge. Using IoT means that I'm using the sensor to determine how much moisture is remaining in my crops, and so do I need to replenish it? That is very, very important for us. So this basically describing infrastructure for rooftop water collecting systems, and definitely we have the roofs, we have the gutters, and this is basically what has been adopted before in the traditional water collecting methods. Now, soil conservation, as we had discussed, soil water conservation, as we had discussed before, the moisture content in the soil is very, very important for crop production and even the growth of microorganisms. And therefore, it is very, very important for us. Now, why would you have this done? to ensure that there is the right moisture content so that you can improve the yields of the crops. That has been mentioned before. So what we are going to look at is actually something that centers on improving soil water content, or soil water moisture in that case. So we are considering a system that has an integration in which we have farming practices that enhance maintaining soil moisture. And these are, okay, we shall have a setup for the same, which is actually here. We have a collection of agroforestry, we have terraces, and we have forage crops right here. These are a multifaceted, a multi-dimensional kind of approach for maintaining moisture content. And you see, you have a lot of cover crops. They help you do the shading, as Professor had mentioned, help you to maintain the soil moisture. Then you have trees which act as windbreakers. You have trees which act as, they also have a shade. Then this is a slopy land. You have ridges, you have terraces that have been built so that you can reduce water runoff, so that at the end of the day, you've maintained the moisture content. Now, there is a critical problem in semi-arid Africa, and this has to be mentioned, because when we speak of a problem, we don't want to treat it as an abstract idea, but we want to point out that this problem is facing this region for us to address it in semi-arid Africa, whereby we have an issue of distribution of rain and the quantity of rain. And this is actually affecting the yields in such a way that we have a lot of land that is unused because it is unproductive because of lacking water. And so this calls for adapting effective water conservation systems. And what are these methods? Mulching using vegetation cover on the soil helps to conserve moisture. That is covering soil surface with a layer of material. And the essence of using that is actually suppressing the weed. Besides maintaining moisture content, suppressing the weed then adds organic matter, as we are going to see. Now, organic amendments, using compost manure, using cover crops, using soils, minimizing tillage, as the sessions before had mentioned, where when you do away with this crop, you don't just do away with the crops and shift them elsewhere, shift the remains elsewhere. They remain there, so they can be used to also help maintain soil structure and improve infiltration in that case. Yes? Okay, yeah. Conservation tillage, something that I've mentioned, minimizing distracting the soil structure by minimum tillage. And there's something critical I've realized about minimum tillage. It is advantageous for maintaining soil structure, then also reducing emission of greenhouse gases and harmful gases to the atmosphere. Because when you use heavy machinery, then we are using a lot of fuel. So this is a practice. Conservation tillage is a practice that needs to be adopted for us to be practicing climate smart agriculture. So cover crops, as we had mentioned before, that one I won't delve so much in that, but it also helps maintain moisture, helps with the water infiltration because of the roots that come with cover crops. And here this summarizes a lot of these practices. Grass to waterway, we have agroforestry, that is trees, cover cropping, use of cover crops, contour farming, responsive to mentioned in the methods, so I won't do repeats, but maybe just to touch on them. Improving moisture, what is the essence of conserving soil water? We are improving moisture, we are improving infiltration, we are sustaining farming through practices that maintain moisture for a long time and all that. So another effective solution here would be being targeted in terms of crops that are resilient to harsh conditions. Given that we have had climatic changes that are so critical in such a way that you can, it's hard for us to predict the weather, then we can move to this. And that is part of what Brian had mentioned. And a lot of research is being done to come up with crops that are responsive to climatic changes, extreme conditions, extreme rains or extreme drought. Do you have those crops? So there's a mention here for counties that are semi-arid, and these are mentioned that can motivate us so that we can look at where can we apply this. You see, I have this concept by where can you apply this. So there's Machakos and Kitui that has been mentioned there. Those are some of the zones where it is very, very critical for us to apply these methods so we can reduce runoff and improve fertility and have a lot of moisture in water for cropping. Now, this basically summarizes a lot that has been covered already, and it reminds us that why are we adopting advanced systems for water collection? We are adopting these so we can capitalize on water collection. And why are we conserving the soil? We are ensuring that we are using every drop that is at our disposal to be put into use. Now, altogether, what does it achieve? Climate smart agriculture, food security, and basically that is the center of achieving everything. So rainwater harvest is not just about the basic use or as limited as it is in our mindset, but it's about sustainability, building lives, achieving food security, and having climate smart practices as a whole. Thank you so much.